Hi guys, I'm just going to talk a bit about inverse proportion. I'm going to do two of the questions which are in the PowerPoint from today. So first of all, normally when you talk about proportion, you say y, whatever variable you've got, is proportional to x, and you can normally replace that with y is equal to kx. So this symbol here gets replaced by equals k. This is called your constant of proportionality. Okay, now this is the normal case where we're talking about direct variation or direct proportion. And you can extend this by saying y is proportional to x squared, and you just replace that with an x squared in there as well. You can say y is proportional to the square root of x, and you replace the x with the square root of x in this formula here. Okay, now that's direct proportion, or sometimes you'll see it written as direct variation. It's just where things are in the same ratio as each other. Now, if you have a situation of inverse proportion, we write it like this. We say y is proportional to 2 still, but we say is proportional to 1 over x, or whatever the variables you are that you have. Okay, and so that can be replaced again, the proportion symbol can be replaced by k times by 1 over x. That's the same as k over x. So we would normally just write it as y equals to k over x. Now from that, it's also kind of useful to know that you can swap these two by timesing by x and by dividing by y. But just if you times by that x, you've got xy is equal to k. So in a situation of inverse proportion, and sometimes people call it indirect proportion as well, but normally inverse proportion. But in a situation of inverse proportion, when you times any two coordinate points together, say for example, I had the coordinate 1, 4, and I know the coordinate 2, 2, well, any two of those points will give you the same constant of proportionality when you times them together. Okay, now likewise in this case, you can also have y is inversely proportional to, I don't know, 1 over x squared. So you could have that instead. So it's inversely proportional to x squared, we would call that, in fact. I said that slightly wrong a second ago. So we would replace that as y is equal to k over x squared. So similar to before. Do another one just to make it clear. If y is inversely proportional to the square root of x, then we write this one as y equals to k over the square root of x. Now, with direct proportion, a normal direct proportion relationship with no squareds or square roots or whatever, if you have this, then when x doubles, y doubles. When x halves, y halves. When you have a situation of normal inverse proportion, so again, no x squareds or square roots of x or cubes or whatever, if you have y is inversely proportional to x, like in this situation here, then you find that when one of the variables doubles, the other one halves. So for example, let's just go back to that case where we had y equals k over x. And I said, well, look, here's a couple of coordinate points here, which would work. Okay, now both of these times together to give you 4. We can substitute one of those coordinate points in if we want to. So we can say, I don't know, let's put in this coordinate point. So we have 4 equals k over 1. K is equal to 4. Okay, so our relationship then becomes y equals to 4 over x. That's the formula. Okay, but you can notice that this one also works there. Okay, 4 divided by 2 is equal to 2. But you can also notice that when you when you half your x number, you double your y number there. And likewise, if you doubled your x number, you would have to half the y number. Okay, so that's a situation of inverse proportion. Okay, so let's have a look at this question given here. So y is inversely proportional to x when x is equal to 6, y is equal to 8. So again, we're going to set this one up like this. Y is inversely proportional to x. So y equals k over x. We'll substitute in our coordinate for 8, and we've got 6, so k over 6, and 8 times by 6 is 48, so that's equal to k. And now we need to set up our formula again. Okay, so there we go, 48 over x. Now find y when x is equal to 9. So now you can put in 48 divided by 9, which gives you 5 point something, or 5.3 recurring, I think. And that's going to be equal to your y in that case. Okay, right, let's have a look at another question. So let's look at the second of these questions. So we're just talking about how this works, the structure of these questions at the moment, not the practical applied version of this. So b is inversely proportional to the square of a. So we're going to say inversely proportional to the square root of a. Sorry, square root of a. And then we've got b equals k over square root of a. If we put b in as 10, and k over the square root of 4, square root of 4 is 2, so k is equal to 20. So now we've got b is equal to 20 divided by the square root of a. Now find b when a is equal to 5, or you can just use that formula now. 20 divided by the square root of 25. We can see 20 divided by 5 gives us 4. So there we go, we've answered that question. Okay, now just one final thing. This does apply in real life situations. For example, just trying to think of one. For example, if in the case of speed and distance and time, okay, for example, if we have a fixed distance, say we have 100 kilometers, and we're looking for, and we've got speed is equal to 100 divided by the time it takes. So maybe it takes 1 hour, maybe it takes 2 hours, I don't know. Time in hours. Basically here, that's a situation which looks like y equals k over x. So there we go, we've set up a version there. And we can think about this in terms of if you half the time that you take to get to a place, then you must have doubled your speed. Likewise, if you half your speed, then that will double the time it takes to get to your destination, which is 100 kilometers away. The other classic type of question here is talking about say for example, let's just set one up. Say for example, it takes 6 people, classic one is with holes, 6 people, I don't know, 2 hours to dig a hole. Then how long does it take 10 people? You know, if they're all working at the same rate, how long does it take for 10 people to dig that hole? Now, this is a situation of inverse proportion because obviously if you double the amount of people, it will half the amount of time. Okay, so again, you would have to set this up in a situation where you would say y is people, if you like, is inversely proportional to time. So you could set it up like that. Or you could think about how long it would take one person. It would take one person 12 hours. And then you could think about dividing by 10 to get, if you've times 1 by 2, you will divide the other one. I'm not making that very clear. Use this formula here, okay? But you could do this by finding out how long it takes one person before finding out how long it takes 2 people. Okay, guys, thank you very much for listening to that. And good luck with the exercises this afternoon.